What's up? This is my physics 2212 lab number 2, charge tapes revisited. This is our table of contents. We're just going to be going over a lot of the same stuff we did in lab 1 and then comparing that to stuff that we had to do for lab 2, which is some new code. So the introduction to this lab, the purpose of this lab was to observe and study the interactions of two charged pieces of tape, calculate the values of force and charge of the pieces of tape as a point charge, and then create a computational model that uses a line charge instead of a point charge. We have our physics principles, which are Newton's second law, Coulomb's law, and then our outcome is that the point charge, the magnitude of the charge, when we use that equation, is 1.4 times 10 to the negative 8 coulombs. And then when we use a line of charges, we find the magnitude of the charge in each tape is 2.613 times 10 to the negative 8 coulombs. So Newton's second law is just F net equals ma, and Coulomb's law is the force of attraction or repulsion. So these are same as the last time, pretty much. So these are the same initial conditions from our first lab. I'm just going to show them here. We're going to go pretty fast through this. And this is the same. Here's our experiment. Surrounding there's our distance. Again, I'm going kind of fast. We can get to the actual lab 2 stuff. So the red stuff is the important stuff that we calculated for lab 1. Primarily the electric charge right here. This is the main value we want to know. And then this was our computational model for lab 1. This rounds up 1.401, and none of this other stuff really matters. So when we do our lab 2 calculations, the difference here is, so for this one, we just use a point charge equation. This one, we're going to actually use the equation of a line to solve for Q. So we know all these other variables. We have R, which is our distance between tapes. We have L, which is the length of the tape. And this equation is straight from the sheet that they give us on the test. So we are given this information. So when you set this to solve for Q, you end up finding that Q is 2.631 times 10 to the negative 8 coulombs. Because we still know that like electric force has to equal gravitational force and stuff like that. And the equation here is going to be Q times 1 over 4 pi epsilon naught times Q over R times the square root of R squared plus L over 2 squared. So this is our computational model. So these are our initial values. This is the actual electric field function from lab 0. I did add mag and norm just to make it a little bit more easy to see. And then this is our line charge. This is given to us. So it basically just spreads the lines, depending on the number of charges you want, spreads them out and acts on both tapes. And then down here, this is our creating the tapes. So this is the only thing we had to change here is this 0.03, and this was the width of the tape. And then you can see n is equal to 50. So I did this with 50 point charges. If you increase that number to like 100, the number pretty much stays the same as yours infinity. This is the second part of the model. So this is our actual calculating our forces and then making the vectors for them, the arrows. So you can see arrows, and then this actually, see these arrows for the field, so these are all arrows are. And then this right here is the net electric force and gravitational force. Once again, I think this is mainly just creating arrows. This down here outputs the E field and the electric force. So this is what it looks like. Blue is tape B that was on the bottom, or tape B is on the top. Sorry, red is tape B. This is tape A. This is gravitational force. This is the electric force, and these are all the little electric forces from each point charge onto the other point charges. So it's like this point charge. How is this one? How everything else affects it? How's it really being affected? Right. So yeah. So for our assumptions and source of error, we assume that air resistance and friction are negligible calculations. That the charge in each tape is uniformly distributed. That both tapes have the same charge. And some errors could be some loss of charge to the handling of the tape, the ignored impact of other electric fields being produced nearby, and just improvised measurements. So for our discussion questions, it's basically just asking what are the two different values that we find and then compare them. So point charge, we found that Q is, as I said earlier, 1.4 times 10 to the negative 8. For a line charge, though, it's higher. So that's pretty much all this one is just asking is to compare the two. But then this one below is the why is, well, why are they different? Well, they differ because we're just using different levels of precision in our calculation. So the line of charge is a lot more likely to be closer to the real value, since in reality the charge is not concentrated at a single point on the table, but instead is across the entire tape. So in conclusion, electrically charged objects, in this case tape, have interaction with other objects near them. We can predict this interaction using known variables and equations. by using different levels of precision in our calculations, we can get much different values for the magnitude of the charge. And using code, we can model these interactions with visuals that show how our chosen model would act in the experiment. So that's it for this lab. Thank you for listening.